take one function and you put it inside of another function, okay? Yeah. Oh, I'm not even using that other one over there if you want to do that. So, a function is performed, and then a second function is performed as the result of the first function. So, how we read something like this is f of g of x. So you see that little circle that almost looks like a multiplication symbol? You're going to notice it's actually a little bit different because it's an open circle, not to be confused with multiplication. Okay, composition and multiplication are two different things. So just make sure you don't confuse the two. That's what that looks like. So when you see that open circle, you know you're doing composition. Alright, so step one is we're going to compose these two functions. So f of g of x is the same thing as f of g of x. What you're going to notice is g of x is replacing the x in the f of x function. So here's how you go about actually calculating this. Whatever function is on the outside, you're going to rewrite that function, but instead of that function with the x, you're going to write it with open empty parentheses. So I'm going to rewrite the function on the outside, which is f of x, but instead of writing in any of the x's, I'm going to replace all of the x's in that function with parentheses. So does everybody see what I did there? Yeah. Okay. Now, whatever function is going inside of that f of x function is what you're going to put inside of those parentheses. So what function am I going to put in those parentheses? X squared, because it's the g of x function. Now sometimes those parentheses are going to be pointless, and since they're not serving any purpose right now, I can just drop them and write my final answer. You got it?
Yeah.
Okay.
Wait, I don't. What happened to the G?
I think you'll see it on the, if you guys don't see it on the next one, let me know, because if I just like tell you now, once it's like one of those topics that like you have to see each step really clearly to see what I'm saying.
Okay.
So this one here, we're trying to find g of f of 2. Before we can find g of f of 2, we first need to find g of f of x. Then, once we find that, we can replace x with 2. Okay? So, notice the outside function. What function's on the outside? G of x or f of x? G of x. Whatever function is on the outside, you're going to take that function and you're going to rewrite it, but instead of x, you're going to put parentheses. Does everyone see that? Anyone stuck on how I got that? Okay, that step's really important. Then from here, what function is going inside of the g of x function? F of x, which is what? X minus 5. Yeah, you have to see it to see it. What do you mean?
I don't understand. What?
I don't know, like, any more simple way to explain it.
Like you put the x
Inside of the other function, yeah. So then from here, if I have to square a binomial, how can I write it out to square it? I have to write it twice and then do FOIL. So first times first, outer times outer, inners, and last. And then I'm going to combine those middle terms, which gives me x squared minus 10x plus 25. Okay? Alright, you ready to see a few more? Hopefully that'll help anyone who's still confused. Okay. So, first we want to find d of h of 4. So we first have to find d of h of x before we can find d of h of 4, right? Oh, wait, on the last question. What did I forget to do on this one? I gotta plug in the 2, yep. Sorry about that. I just did the x part and then I forgot to do the last part. So that's gonna be 4 minus 20 plus 25.
Like where the 2 come in?
Oh, so the original question wanted me to plug 2 into it.
Okay.
So I totally forgot to do the 2 part. So that's going to be a negative 16 plus 25, which is 9. Now, what you might have already noticed is if you would have plugged the 2 in earlier up here, what's 2 minus 5? What's negative 3 squared?
9.
You could have done it that way, too.
What?
Well, I just want to make sure you understand, like, how everything works. Okay. So this one here, we have to find d of h of x. Once we find d of h of x, we can plug in 4. Okay. So what function is going to go on the outside, be written without the x?
Plus 3.
Good. So all I did here, I took this function and I wrote it, but instead of x, I put what?
Oh.
Parentheses. All right. Everybody good with that?
Yes.
Now, what function is going to go inside those parentheses?
X squared plus 7
X,
plus 6
x squared plus 7.
plus 6.
You see, I took the h of x function and put it inside of the other function. Okay? Now, are these parentheses necessary in this one? No. I can just drop them and combine like terms. You see that? Now, what do I need to plug in for x in this one? 4. Which gives me 16 plus 10, which is 26.
How do you know you could have just taken the 7 out? Oh, because.
Wait, what's 7? Oh, I didn't take the 7 out. I was just adding these.
Okay.
So for the next one, I'm trying to find h of d of x. So what function am I going to write without the x in it?
X squared plus 7.
Yeah, so what you're going to do is whatever function is on the outside is the one you're going to write without the x in it. You see that? So I wrote that function on the outside without the x. Now what's going to go inside of those parentheses?
X plus 3.
Good. Now, you could technically leave it like that if they didn't specify, but if you wanted to expand this, how could I multiply this out right here?
Do it twice.
I got to do it twice. Good. Good. I don't want to see any of you Algebra 2 kids trying to square each one of those terms. That's Algebra 1 mistakes, so don't do that. So we multiply out, and we get this. And then now what can we do? Simplify, combine like terms. Good. Alright, how's everybody feel about that one? Good. So you're going to notice that probably 99% of you today have a calculator on your desk because we're going to be working with some numbers that, aren't so simple. So you're going to need that. What?
Don't we have to plug it in?
Oh, see how this one doesn't have a value to plug in? So when there's no value given to you, you leave it in terms of x.
Okay.
So that's good for everybody here. So you see how this one here has a 4 plugged in? That means my answer is going to be a number. See how this one has an x? That means my answer is going to have x in it. So that's a way to kind of verify. Alright, so this one says, suppose you have a $5 off coupon for a large pizza at Pizza Hut. That would be represented by the function f of x equals x minus 5. So in the function f of x equals x minus 5, what does x represent? Good, the cost of the pizza, original cost, of course. And then you have a 15% off discount. So that function would be represented as g of x equals 0.85x. So I want to talk about that one because it's not as intuitive. If you go to the store and you get 15% off an item, what percentage of that item are you still paying for? 85. So everybody see where the 85 came from. Now, in addition to that, when we're dealing with percents in math, we need to convert them to decimals in order to utilize them, right? So that's what they did there. Okay, that's where the 85 came from. I just want to make sure everybody understood where that came from before we go to the next step. Okay, so we want to know which discount would be more beneficial to apply first. Okay, so in order to figure that out, we're going to compose these functions, right? We're going to do one and then the other, one and then the other. So we're going to have to find f of g of x, and we're also going to have to find g of f of x. Now in each case, what is x going to be replaced with? What is x going to be plugged into? or what are we gonna make X? The price of the pizza before any of the discounts, which is $27.85. So I just want to point out to you guys another way to do composition. So when you go about doing composition, you don't have to do all of the algebra stuff first. You can actually do the calculations first. So you can work inside out when there's a number in there. So if I want to solve this one, I'd first want to work inside out. I want to find g of 27.85. How could I find that? Yeah, so I'm going to, bless you, take the g of x function. I don't need to write all of that out. I can take the g of x function, and I'm going to replace x with 27.85. And whatever I get when I do that is going to be what I'm taking f of. So 0.85 times 27.85. So that gives me approximately 23.67. So am I done with the problem? Do I have the final answer?
No.
Now I need to do f of this amount. So to get that, I'm going to plug this into the f of x function. And that's going to give me $18.67. So this situation, what we did was we did 85%, then $5 off. So we took off the percentage, and then we did the $5 off, okay? So for the next one, we're going to start the next one by taking the $5 off, then doing the percentage. So I have to find f of 27.85. So that f of function is going to be this one. So I'm going to do 27.85 minus 5.
22.85.
Good, 22.85. And now I have to do g of that. So I'm now going to take 22.85, and I'm going to multiply that by what? 0.85. So that's going to give me my answer, which is going to be something. I don't know. Good. $19.42. So this is when you take $5 off, then percent discount. So the moral of the story here is it better to take the flat dollar amount off first and then the percent, or the other way around? What do you guys think? Percent, then dollar amount. Okay, so now you know that for future reference. Okay? Because some places I've been, they make me tell them what order I want the coupons. I mean, they don't know I'm a math teacher, but they make me do that because they think you're going to trip it up. So.
Doesn't everyone know the higher the number, the more percent? You wouldn't have
Well, I think people just automatically, they think like the dollar amount one is always going to be better.
Yeah.
So it's really just one of those things that if you don't like think about it mathematically, it's just, you're not really sure. My guess. All right. Is everyone good with that?
Yeah.
All right. So for the next one, it says a new car dealer is discounting all new cars by 12%. At the same time, the manufacturer is offering a $1,500 rebate. So does everyone in here know what a $1,500 rebate is?
No.
Or what a rebate is in general?
No.
So I'll just kind of clarify that for you guys. A rebate is basically where you pay for something and you get part of that money back later. So they're saying you pay for the car and then you get $1,500 back. So it's basically just the same thing as the last one, like a $5 coupon. But it's like obviously for bigger purchases, they call it a rebate. So I just want to make sure you all know what that is. So it's similar to the $5 off. So the car that they're purchasing is $24,500. So we want to figure out if it's better to take the rebate and then the percent, or the percent and then the rebate. So, first and foremost, we have to write functions for both of these. So, for the percentage, I'm going to call it f of x. If they're taking a 12% discount off of the car, what amount are you going to pay? 0.88. And then, what's g of x going to be? The price of the car. Good. Minus 1,500. And then what am I going to be plugging in for x overall when I compose these?
24,000.
Good. So I have to find f of g of 24,000. And then I have to find g of f of 24,500.
What does G stand for?
Oh, it represents the rebate, the price after the rebate.
Okay.
So step 1 is we're going to solve inside out. We're going to find g of 24, whatever that is. So how could I find g of 24,500? I'm plugging it into which function? Yeah, I got to take 24 and I got to plug it in right here, right? So when I do that, I get 23,000, right? Did I do that right? Okay. Then I have to do f of that amount. So that's just going to be whatever this is, right? Which is good, 202.40. So that's the price if we take the rebate and then the percent. Now let's try it the other way around. Here we're going to take the percent first. And then the rebate.
21,560.
Good. And then to get the actual, we're going to do this minus 1,500. Okay. So which one's better, the left or the right? This one's better. Yeah, you save a little bit more money, right? So the moral of the story here is composition does matter the order, unlike multiplication and addition. Composition is more like subtraction and division, where the order does change the final answer. Alright, so now that we've done that, we're going to talk about inverses a little bit. So two functions are inverses. Essentially, when they are reflections over the line y equals x, that's the line that goes diagonally through the origin. We're going to talk more about inverses as we get into the course, like the next few lessons and whatnot. But for today, we're just going to learn how you can confirm if or if not something is an inverse. So the rule is if you compose two functions both ways, meaning you plug one into the other, plug the other into the other one, and your final answer comes out to be x for both of them, just plain regular x, that means they are inverses. If it comes out to be anything except for x, they are not inverses, and they have to both come out to be x. So we want to check and see if f of x and g of x are inverses. So to do that, we're going to have to compose them. So we're going to do f of g of x first. So back to what we were doing before. Which function am I going to write out with parentheses?
F.
Good. So I'm going to write the outside function, but instead of x, I'm replacing the x's with parentheses. Now what's going to go inside of those parentheses? Good. Now from here, I can then do what? And I get what? Good. Did that come out to be x?
No.
So are they inverses? would we need to go ahead and try the other one at this point? Do we need to try it the other way? No, because we've already ruled it out, right? So maybe on a test or quiz when you like might have made a mistake, you might want to check it, but we don't have to do it the other way because we know that it's already not an inverse. If it comes out to be x, you have to check the other one. Yes.
So when it converts, what does it look like?
What?
What will it look like?
It's gonna come out to be just x. We're gonna do one like that too. Don't worry. So you could check it and verify this is also not x if you want, but you don't have to. Alright, so we're gonna check and see if these are inverses. So what am I gonna do to start this one?
The G of.
I gotta write the f of x,
Oh.
but I have to replace the x's with what? Parentheses. What's gonna go inside of those parentheses? The other function.
Square root of x minus the.
Yeah. Good. So here's the thing I want to mention, like, sometimes you're going to end up with too many parentheses. It's better to have too many than not enough. Okay, it's okay to have too many sometimes, because at least that way everything's separated the way it needs to be. Now you can see these parentheses on the inside are unneeded. What's going to happen with the sixes?
Cancel.
Good, so I'm left with the square root of x squared, which is what? Just x. So does this one have potential to be the inverse? Yes. I have to check the other one though, because if one of them's x, that's not enough. They both have to be x. So now we're going to check the other one. So I'm going to write the g of x function, but instead of x, I'm writing parentheses. Inside of that function, I'm putting the g of x function. In math, square roots reverse squares and vice versa. So what's going to happen with the square and the square root? Which leaves me with x plus 6 minus 6, which is what? X. So are these inverses?
Yes.
Yes, inverses. Now I want to make sure you guys are aware of this. What if they both came out, each one of them, both of these calculations came out to be 2x? Would they be inverses? No, they have to each be x. So I want you guys to try the other one on your own. Can you pass out the homework for me? It's on the top there.
I think I'm on that one question that you and Sebastian are struggling on.
Oh, yeah, yeah.
I don't know.
I'll help you with it.
I literally wrote it all correctly. It was just, it wasn't like how they wrote it.
Yeah, it was like frustrating.